This clip reviews how to solve linear systems by using elimination. The problem asks to solve the system 5x plus 2y is equal to 7 and negative 3x plus y is equal to 9 by elimination. By solving the system, we will find the point of intersection of those two given lines. The problem in the blue box is for you to complete as we go through the solution for this given problem. I'm going to start off by rewriting and numbering both of the equations. So I have 5x plus 2y is equal to 7 and negative 3x plus y is equal to 9. And I'm going to label them 1 and 2. By numbering the equations, it's a good way to keep things organized so as you go through your solution you know which equation you're referring to. I'm going to solve this type of system using 3 steps. In order to solve the system by elimination, we need the same coefficient in front of the x or y variable. This is what we do in step 1. Right now, looking at these two equations, we can notice that none of the coefficients for any of the variables are the same. So what we need to do is multiply one of the equations by a number to get the same coefficient in front of one of the variables. I'm going to choose equation 2 and I'm going to multiply it by 2 so I get the same coefficient for the variable y. So I'm going to start by leaving 1 alone and just rewriting it. So I get 5x plus 2y is equal to 7. I'm then going to take equation 2 and multiply it by 2. So I need to multiply each term by 2. So I have negative 3 times 2, negative 3x times 2 is negative 6x. Y times 2 is plus 2y, and 9 times 2 is 18. I now have the same coefficient in front of the variable y. So I'm going to eliminate y. And in order to eliminate the y, since I have the same signs on the two y's, I need to subtract. So I'm going to subtract the two equations. So 5x subtract negative 6x is 11x. And then as we're eliminating the y's, 2y minus 2y is 0. Then we get 7 minus 18 is negative 11. I now solve for x, and x is equal to negative 1. And so I'd like you to try step 1 for your problem. The solution to your problem is shown in the blue box. I'm now going to move on to step 2. In step 1 I found the x value of this point of intersection, and now in step 2 I need to find the y value. So in order to do that, I need to sub x equaling negative 1 into either of the original equations. And I'm going to choose equation 1. So I'm going to sub x equaling negative 1 into 1. So I have 5 times negative 1, that's my x value, plus 2y is equal to 7. So then I get negative 5 plus 2y is equal to 7. I want y by itself, so I'm going to bring the 5 to the other side. So I have 2y is equal to 12. And then solve for y. Y is equal to 6. So I've now found the y-coordinate of my point of intersection. So I'd like you to try step 2 for your problem. Again, your solution is shown in the blue box. I'm now going to move on to the final step, which is step 3, and we're going to check x equaling negative 1 and y equaling 6 in both of the original equations. So my first equation is 5x plus 2y is equal to 7. So I need to do the left side, right side check. So the left side is equal to 5x plus 2y. I sub in my x and y values and I get 5 times negative 1 plus 2 times 6. I get negative 5 plus 12 is equal to 7. My right side is equal to 7. Therefore, the left side is equal to right side. And this means that the point negative 1, 6 lies on this line. Let's check equation 2, which is negative 3x plus y is equal to 9. So that's equation 2. Okay, left side is equal to negative 3x plus y. Sub in my x and y values. I get negative 1 plus 6. That is equal to 9. The right side is equal to 9. Therefore, left side is equal to right side. So that means the point negative 1, 6 lies on this line, which is great. Therefore, my last concluding statement is the solution is negative 1, 6. So that point, negative 1, 6, is the point of intersection of those two given lines. Okay, so I'd like you to do your left side, right side check for your problem. Your solution is shown in the blue box. So as we've seen, this system of equations can also be solved using substitution, which was what we did in the previous clip. So we can solve a system of equations either using substitution or elimination.